Today, I want to tell you about an agricultural discovery that has really big implications for African farmers. Currently, farmers in West Africa have to deal with inconsistent rainfall and frequent drought, which, unsurprisingly, can make it really hard to produce crops. It's hard to stay consistent and reliable with your crop production when the sky isn't consistent or reliable with its rainfall. This is troublesome for many reasons, with the most pressing reason being Africa's dependence on locally produced foodstuffs, as well as its rapidly growing population and the little to no increase in food production that we've seen despite adjustments in growing techniques. But there's been a recent discovery that could largely mitigate the issues with drought, or at least as far as millet crops are concerned. Professor Richard Dick is a soil scientist at Ohio State University, and he was in Senegal in Western Africa during a recent period of drought. He noticed an indigenous plant, a low-lying woody shrub called the Guera senegalensis, that appeared to be doing just fine, despite the lack of water that was punishing everything else. It turns out that these Guera senegalensis plants are able to resist drought because they grow very deep roots, like 30 to 40 feet down, which allows them to find and tap into more distant water sources. Water from this more distant source can be slowly moved up to the base of the plant, which brings the water from deeper, wetter soils up into shallower, drier soils, using the Guera plant's roots as a travel corridor. Now, during the nighttime, when the sun is down and photosynthesis isn't helping to pull water up the stems and out of the leaves through transpiration, this water pulled up from deeper soil will leak out of the Guera plant's shallower roots. This nighttime leakage in the upper soil will moisten the soil, and this will allow all of the other plants nearby with shallower roots to be able to enjoy a nice morning drink. Needless to say, this offers them some protection, some respite from the brutal conditions of the drought. Now, I should clarify that this discovery isn't exactly completely out of the blue. There have been a plethora of previous studies that have examined this process of water being brought up from deep underground sources that leak out in the upper soil to help surrounding plants. There have been a lot of studies that have looked at how this can work in various ecosystems to support floral biomass where we wouldn't expect it, because maybe it's either too hot or too dry or something like that. Mr. Dick wanted to see how this shrub could affect local agriculture, and so him and his research team created an experiment that radically differed from the local agricultural techniques used by West African farmers. Local farmers would usually selectively rip out these woody Guera plants and just burn them as waste, and the result of this selective harvesting and burning would leave them with about 300 individual Guera plants per hectare of farmland. But instead of removing and burning the Guera plants, the researchers decided to add as many of them as they could fit into their cropland, something close to 1,500 plants per hectare, which is 5 times as many as the local farmers. And instead of burning the remains of these plants, instead of burning the detritus and just turning it into carbon dioxide and heat, they would decompose them. They would decompose the remains and use them to fertilize the field. Now, farmers in West Africa are known to grow many things, but among the staple foods that they grow, there's a grain called millet. The millet plant has shallow roots, and so during a drought, these plants tend to suffer and they struggle to grow, and their crop yield can get really bad. But when the researchers grew the millet in this crop field that was loaded with Guera plants, the total yield from the millet crops increased by 900%. The Guera plants acted like a kind of natural bioirrigation, but instead of being arranged horizontally along the landscape to help water run from one place to another, they were arranged vertically to suck water from deeper soil up into drier, shallower soil, where it could then be dispersed and shared among all of the shallower plants. This effectively kept the millet plants from suffering the symptoms of drought. And because they had a relatively stable water source, thanks to the water redistribution efforts of the Guera plants, the millet could then grow and produce a very large amount of grain. A 900% increase in crop yield is amazing. I mean, you can't ignore that. When asked to describe these results, Mr. Dick said, quote, "We proved that bioirrigation by these shrubs is happening, and it's the first time that this has been shown for crop production. This is a native plant, and it's free and easy to grow. Everything about this is positive," unquote. I think that this is the best part of this discovery. There's no big corporations or intellectual property involved. There's no massive research fees. There's no royalties that the farmers have to pay. It's literally a wild plant. It's native to the area and it grows everywhere. These plants can be identified and harvested by anyone, freely and easily, and even the most humble farmer can plant its seeds in his crop field. This kind of natural, biological solution is an incredible breakthrough, especially for West Africa, and for farmers in less industrialized nations across the world. These farmers, who are typically less wealthy and don't have access to fertilizers and farming machinery, they can utilize this growing technique for free, and if these results are anything to go by, their crop production can potentially skyrocket. This is great news for the farmers, who now have the knowledge and the potential to produce a lot more food with relatively little investment, and thus they can make a lot more money to support themselves and their family. And it's great news for their local communities and for their nations, as the increased food production, even during droughts, will improve their food security. This might seem like a relatively small discovery. I mean, you're just taking one plant and growing it closer to another plant. I mean, what's the big deal? The big deal is that this very simple, very easy, very cheap agriculture technique can potentially save thousands of lives. That is why this small little discovery is so amazing.